Hello everyone. If you love the right triangle like I do, or are just on a break from cute cat videos, you may find the next few minutes interesting and even useful. Please bear with me for a very brief backstory. I woke up a few mornings back, sequestered from the world of COVID-19, and started thinking, of course, about right triangles with whole number sides. These are known as Pythagorean triples. It crossed my mind that for many of those triangles, the hypotenuse was only one more than the longest leg, for instance, the 5, 12, 13 triangle. After some early morning mental gymnastics, still in bed, I thought of a very simple method for calculating an unlimited number of Pythagorean triples. And I'm going to share that with you right now. Here's a picture of a right triangle. A squared plus b squared equals c squared. That's the Pythagorean theorem. And Pythagorean triples, 3, 4, 5, 5, 12, 13, 7, 24, 25. And you notice that b and c are only one apart, 4 and 5, 12 and 13, 24 and 25. That got me thinking. I always thought and even taught that these needed to be memorized. But what if you just choose any odd whole number greater than 1 for the length of the shortest leg, for instance 7, square it, get 49, subtract 1 from that, that's 48, divide by 2 is 24, that's your long leg, add 1 to that, 25, and that's your hypotenuse. Let me show you that in the form of an equation. A squared minus 1 divided by 2. That gives us the longest leg. Add 1 to that. That gives us the hypotenuse. In fact, all of the triangles that you find this way are known as primitive Pythagorean triangles, which just means that there is no common factor to the three numbers. Okay, so now you're probably wondering about the poor neglected even numbers. The good news is that they have their own very simple method, which is just slightly different from the method for the odd numbers. First, choose any even whole number greater than 2 for a leg of the triangle. Divide it by 2, square it, subtract 1 to get the other leg, add 2 to get the hypotenuse. Let me show you. We'll use our ever popular 8, 15, 17 right triangle for our example. First thing we do, slightly different than the odd numbers, we take our A, divide it by 2, and square it. Then we subtract 1, and that gives us our leg. 8 divided by 2, 4, squared, 16, minus 1, 15. We've got our long leg. Next, we add 2 to that. 17, we've got our hypotenuse. Straightforward, and you could probably do it in your head with a little bit of practice. One important thing using this method for even numbers, the hypotenuse must always be an odd number in order for a triple to be a primitive triple. In other words, once you've done your work, if you come up with an even numbered hypotenuse, you know you don't have a primitive triple. You still got a Pythagorean triple, but it's not primitive. In fact, half of the triples that start with an even number are not primitive because the hypotenuse is even. So the three sides will have a 2 as a common factor. Like take 10, 24, 26. 10 divided by 2, 5 squared, 25, minus 1, 24. Add 2 to that, 26. So that's a 10, 24, 26 triangle. But those are all even numbers. If we divide them by 2, we get a 5, 12, 13, which is a primitive, but a factor of 2 makes 10, 24, 26 not primitive. And finally, I hope you'll agree that these two methods are easy to use and give you lots of fun triangles. And you could probably even calculate them in your head. But they don't give you all of the possible primitive Pythagorean triples. But we can talk about that, the rest of the story, in another video. Thanks for watching.